Um, so thank you everyone who show up in the room. It's about, there's 2, 4, 6, 8, about 10 people in the room and about 6 people online. So that's, and I will try, I'm very used to be the one online. So I will try to be very nice to the online folks because I know it's very hard to be there. So thank you for being online for me today. And thank you, Alison, for bringing me to Iowa. It's been since 2019 that I'm not here. And thank you, Joe, for also organizing a lunch at the Biostats department later. I'm getting nervous now. and it's nice. It feels like being home. My first time in Iowa was in 1999. So it's been, I've been coming back and forth for a long time. So today it's, and for those who are online, if you need to ask a question, please raise your hand and or use the chat, and Juliana would let me know that you want to, and you can open your mic and talk to us, and we can all listen. And for those of you in the room, please interrupt me anytime. Okay, let's try to make this a dialogue so you don't fall asleep in the middle, and let's do this very informally, okay? So, and I hope you have about 50 minutes to talk about open science. And I want to show you a little bit, and well, if you need the presentation, follow that QR code, and it's online, and it's on a repository called Zenodo, and if you want to reuse it, you can, because it's licensed. And if you need to reuse it and you want to cite it, you can, because it's like a paper. And that's part of open science too. So that's that. And I forgot my clicker, so okay. I will try to pass to the next slide without throwing anything to the floor. There. So there's, I will start by what was my path to open science. It was a long one and a very slow one. So if you have doubts about what I'm going to tell you about open science, you might discover that you have a right to your own path, and it doesn't have 100% to it. And I thank you for that note. I love those. So I'm going to show you mine, and been working in biological medical sciences, which is my guess that I know for some of you, you deal with health data, and open science gets a lot tricky when it's health data. And I hope, I didn't check, can the folks online hear me well and see my screen well? Let us know, please. Okay, thank you, Janelle. So, I mean, it gets very tricky because today's, I keep doing some research with health data, and I haven't been able to open everything. And it's okay. All right. So, and if you cannot open everything, that doesn't mean that you cannot do open science. All right. So this is how it started. It started over more. I've been doing research related stuff over 30 years ago, because I started very young relating myself to research when I was in high school already. This is me receiving my high school degree in Buenos Aires. And I had already some experience at a museum with paleontology at that time. And at that time, I was already working in a wet lab in a molecular biology institution in my country, which is pretty renowned. And I was an undergrad RA, because at that time I was already in the first year of the undergrad biological sciences degree. And this is how it's going today. So I'm the executive co-director of a nonprofit. I'm a tenure researcher in the National Research Council in Argentina, and I'm an open science NASA and ZZI principal investigator. ZZI is the Chan Zuckerberg Initiative. What happened in between? Of course, right line, right? like a straight line. And those who are laughing is because they know my path. No, I was nothing but a straight line. So I don't know, those that give you the story of the straight path, that doesn't exist. Okay, so 1985, I started the degree in biological sciences. I was a molecular biology RA. That first year in a wet lab, I discovered I was not interested in molecular biology. I tried bioinformatics in 1996, didn't like it. In 1997, I thought I was falling off the system forever because my dad was sick and I had to become the head of my family. But luckily he recovered and I went back. Then in 1998, well, I decided to add computer sciences to my another degree because not enough with biology. I liked computers a lot. And in 1999, I got into a neuroimaging research assistantship and I started doing some clinical research in Buenos Aires. And I decided, no, computer science is not for me. I mean, clinical research is what I really like, so I need to write it in biology. And that year, through the neuroimaging RA-ship, I came to Iowa for the first time. And this is when I met Steve Arndt, who became my lifetime mentor. Hi, Steve, I know you're online. So, and in 2000, I came back for a second workshop. It was a brains software that was developed in the CRC in the General Hospital by the group of Nancy Andreasen. For those in psychiatry, they know who I'm talking about, and some of you may also know who I'm talking about. She was very famous. She is, I don't know. Okay, sorry about that past tense. And at that time, and I don't know if Brains was open source or not, because that would have been my first approach to open science. If Brains was open source, that would have been my first approach to open science. I couldn't go back and check it really, because it's ancient history, but I don't know. Do you know if Brains was open source, Doug, at all?
I don't know if it's technically open source.
Okay.
Johnson is willing to share it pretty readily. But...
Yeah, I mean, but it was not openly published. Yeah, we used it in Buenos Aires, but we couldn't contribute to it, I think. So that would not make it open source. So it was free to use. So it was pretty close, but 2000 open source was just starting, right? So it's ancient history, sorry. I mean, for those that are very young in the room, I hope I'm not boring you. When you get close to 50, then you like stories. And in 2000, that second visit to Iowa, Steve told me, what are you gonna do when you graduate, Laura? Have you heard about biostatistics? I was like, biostats, what? And you should consider the program in the College of Public Health. It's very interesting. It's very good. So, okay, sure, I'll apply to the master's, and surely I did, and I got in, and then I said, maybe not. And then December came in 2001 in Argentina. It was one of the biggest crises, economic crisis in my country. The banks kept all deposits, so we couldn't get access to our money. And January 2002, Terry Kirk sent me an email the day of my birthday saying, Laura, the time of your application is about to expire. Would you like to come or not? I was like, yeah, sure. Where do I sign? So I came just with the 600 bucks that I had to fly to Cedar Rapids from Buenos Aires. And I got into, I I did the biostats program, and I continued doing neuroimaging in psychiatry under the supervision of Ricardo Jorge. And everything was paid for me. So it was a great opportunity. I was letting pass myself. But thank you, Terry. So I got my master's in 2004. I continue. At that time, I started doing more than neuroimaging. I started designing clinical trials and analyzing more general data for psychiatry. I continue my RA-ship. And of course, Steve talked me into the PhD program. And the year I met in Buenos Aires, my husband to be. This is the mathematical notation, the only mathematical notation you'll get. And Joe, sorry about that. So, well, in 2005, I thought I was going off the loop again because my mom had stroke in Buenos Aires. So the next day, I took a flight back. But I spoiled the story because no, it doesn't, I don't go off. That same year, this is the point that I identified like my first open science enabled paper. Why? Because again, thanks to Steve Arndt, I hope you're not getting very blashed out, Steve, online. We published the first open science enabled paper. This is a paper that was possible thanks to open data. Identify data published by SAMHSA on older admissions to substance abuse treatment in 2001, where we describe the admissions to treatment for older folks. And it was very interesting to know what was going on with this substance abuse treatment. And this is also what I consider my first approach to what is now called data science, because this is a large sample size that you can, a large data set that you can query and you can ask questions, research questions too, and you can reuse for other purposes. So, and it was thanks to having open data, which is part of open science. So in 2006, from Buenos Aires, so this is when my remote work starts, way beyond, way before we had all these systems and Zoom even existed, or the cameras. It was like, Skype existed already, so I was able to call by phone through Skype. Internet existed, so and I got along well with computers. So so I kept working as an RA-ship for psychiatry. My RA-ship, I studied for comms. I started dissertation. And all that was possible because I had enablers. The one, this is Ricardo Jorge, who allowed me to keep working remotely. He was open-minded enough to keep me to allow me to keep working remotely when mode was not a thing. I don't know if you remember, but before 2020, it was not a thing. So he accepted me working remotely from Argentina. Catherine Chandler, the former head of the Department of Biostatistics, she also was very, very nice at saying, you do what you need to do, and with all the, I follow all the rules, but still, they were super nice at the Department of Biostatistics. And that guy there, Joe Kavanagh, he accepted me as a PhD student for the dissertation remotely. That he took a chance, definitely. Now that I have PhD students, he took a chance. So, well, surely enough, it took me a while. In 2011, both my parents passed, and that same year, I got my PhD. I defended my dissertation in one room in the General Hospital. And then in 2012, I got pregnant. I got my first son. My first son was born. Was a better way to phrase it, sorry. And in 2013, well, until now, I thought research was my thing. And I was not going ever to, Catherine told me one day, it's like, have you considered teaching? No, not at all. No, I would be a terrible teaching, forget it. And she said, okay, why don't you try it? And surely enough, I taught this summer class for the University of Iowa of introductory biostatistics, and I loved it. It was remote, no camera. I spoke to the void. I interacted through chat, and it was a very good experience. And that's when my passion for teaching started. And that's important, and you'll see why. And in 2014, my second son was born. And something very important. My dissertation, all written in R, which is not a language we use well, now it's more used, but in health sciences, SAS used to be the king, and that's closed source. But R is open source, and without R, my dissertation could have not been written. Not even speaking about having SAS in Argentina and its cost, okay? And why I'm bringing up Luke Tierney here? Well, because he's in the Department of Statistics, and he's a big deal in R. He's an R core team member still. So without him, and others, there's no R. Okay, and if you're wondering, those are the son 1 and 2 and the husband that it's like husband now. Okay, 2013, this is my first author. Again, it's closed access because addiction, you have to pay to read it, unless there are options. I will not get into that detail now. But first author of Open Science Enabled paper, because again, looking into open data published by SAMHSA, we identified there was an increased risk of alcohol and drug use among children from deployed military families. And I was the first author of that one. Of course, Steve is in the list of authors because, yeah, he's a great colleague. In 2015, I had a very difficult reinsertion in Argentina's research system. And I became aware of something that is a buzzword in the open science movement, which is a reproducibility crisis. It's called also the replicability crisis. I mean, there's different words to it, but I will stick to reproducibility, which means that if I give you the data and the code, you are able to run the analysis I run and get to the same numbers I got for the results. And easy peasy, right? He knows it's not. No, it's not easy peasy, even if I give you the same code and the raw data. Well, sometimes it's not the raw data. Well, it's complicated. Those words, and at that time, it was the American Statistical Association declaration on the p-value and the problems of the p-value. And I don't know if the statisticians in the room know about it, but I started talking about it and looking more into it. I had presentations and talks done about it. And so that was more my approach to open science, and I started looking more into it. And then the data science buzz got to my ears as well. And I said, oh, it seems like what I'm doing might be data science after all. In 2017, I became aware and involved with Our Ladies, which is a group of the R programming language that wants to increase the gender diversity in the R world. And I co-founded Our Ladies Buenos Aires and encouraged Our Ladies to grow in Latin America. And through that network, I got to other open science communities. And I networked throughout a lot of other communities. And that let me build a lot of social capital that I think was essential to get me funded today. So for the young people in the room, that's important. And at that time, I was almost out of academia. I said, if by December this year, I'm not into the national research system in Argentina. I'm out. I'm going to do consulting. Basta. That's a word you understand, right? Okay. So, well, November, I got like the letter, yeah, your tenure. Good. And so I got in, and at that time, I was also an instructor and trainer certified by one of these communities of practice with good pedagogical ways of teaching. So how are we going doing Fox Online? Is everything okay with you? Because I can see the faces here in the room, but are you asleep already? Good. Thank you. All right. In 2019, so as part of being a researcher, I started putting together something that I named Collaboratory for Responsible Use of Data, which is applying what I know from biostatistics, so more general data science and AI, artificial intelligence, because like data science started calling itself artificial intelligence. I mean, this thing that keeps moving target, the naming keeps changing, is still data being analyzed. It drives me crazy how computer science rebrands all the time. Joe is smiling. Okay, he must have opinions. Okay, and 2020, I will not remember you what happened to humanity that year, but everything was turned upside down. And the way I found to help was to start teaching to teach how to teach online in March 2020, because I knew how to do stuff online very well, because I had all these experience since 2006. And also I had all the experience training online and being an instructor online. And so I volunteered and with a group of other folks through the open science communities, and we call it metadocencia. And the name was my husband putting it together indeed. And if you care about stickers, there are stickers here. Because in open science, we like stickers. Yeah, and hexagons. Well, that's more the artwork though. But I knew volunteering was not going to take us very far, that I needed funded, that I needed to apply all the experience I knew from my research time applying for funding. So I started looking for funding, and surely enough, in 2022, we got a Chan Zuckerberg Initiative grant that made us sustainable for a couple of years. And that enabled us to apply for another grant, for a couple of other grants to NASA, and to do community-based teaching open science 101 in Spanish. And that's what I'm doing now. And everything that is in black letters is related to open science. So that's my path to open science. Of course, in the meantime, I kept being a researcher, and there's been several papers. I turned to open access every time that the article processing charges were able to be paid, which is not obvious, not here, less in Argentina. And also open data enabled publications. This is a review, so it doesn't have data on it, but this is one of the publications that we put forth with Alison. One of the several. And with Ben, yeah, you're here. I'm meeting Ben for the first time in 3D, so thank you for coming, Ben. Okay, so metadocencia, which means meta teaching for those of you who are not experts in Spanish. It's a nonprofit, so essentially I'm co-leading a nonprofit. A weird path for a biostatistician, I guess. Did you expect that from me? No, right? We seek to advance innovation with a local perspective that builds scientific and technical capacities by co-creating networks learning spaces and accessible resources for Spanish-speaking communities. And I speak about communities because this thing of communities that I mean, communities of practice is a way that have allowed me to go through an alternative path to academia. Academia can be very, well, I almost fell off the wagon several times, okay? You've seen it in my timeline, and I almost fell off again in 2017. And so it's very hard to stay put when you have care responsibilities, when you're a minority, et cetera, et cetera. And when funding is scarce, I know you can all relate to this. Even if you stay in it, it's difficult, it's challenging. And for younger generations, it's very hard to get tenure these days. Okay, so there's alternative paths, and these communities of practice are more horizontals and not alternatives. So not the nonprofit sector, it's becoming an alternative. And through these communities, there are like the professional associations, but with no fees, free to belong. You just go there, work there voluntarily, you meet people. That's how I've been doing it. So, and it's not something very known until you get there and invest some time. So maybe that is helpful for the younger in the audience. Okay, and this is another community that it's part of, I mean, Metadocencia belongs to now, which is the Transform to Open Science TOPS community. You've seen this before, and there's the NASA logo there. And I'm like in that picture somewhere. Oh, okay, I don't know what, oh, maybe because I should, oh, no, okay, just stay away. So, that image was taken in February in Florida and Cape Canaveral, where the rockets go up. Yeah, it's hard to be so near rocket science. But open science is not rocket science. Please do not confuse it. So some of the following slides are made possible thanks to the work of the entire TOPS community, which is like over 3,100 folks. Just wanted to give credit for things I've taken in the next few slides. So I'm tired to speak, to be speaking so much. What do you think it's open science? And this is a question for the folks online too. I guess something, come on.
Data sources and publishing.
Doug Langbank says that open science include open publishing and open data sources, and I agree. Anyone else? Do you want to add something, Joe?
Yeah, there's data analysis providing the code.
Data analysis providing the code. Alison.
You know, I think what I've learned from you, Laura, just in getting to know you as you've been going through this, your career path, is, you know, science gets presented to us in elementary school as this something, it's sort of very pure, anybody can do it, right? It's, you know, it's a model that's accessible to everybody. And then you realize that in working in an academic center and then talking to people who are not necessarily in that academic center, that it's not as accessible to everybody. It's very, there's a lot of resources that are needed. You have to kind of buy your way in and or have resources in order to participate. And so I think of open science as a way to try to create a platform and a space to actually do science without having to have all of the financial resources and to sort of pay to play.
Wow. Did the folks online?
Steve mentions that it is available to reproduce the results.
Yes, Steve, absolutely. And Alison, you did a more general thing of open science. It's a way to democratize science and to make it available for everyone. And that's the most general view, which include opening the code, opening the data, opening the publications, and yeah, opening the resources to everyone. Absolutely. Yeah, okay, well, I can go now. Okay, let me bring you one definition. This is the White House definition. It's a principle and practice of making research products and processes available to all. There you go. While respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. That's the definition from the White House Office of Science and Technology from last year. So, goals of open science, pretty much what you said, Alison. Facilitate collective benefit, so everyone can benefit from science. Achieve inclusive development and innovation, realize equitable outcomes. These are very beautiful words. Let's see how we get there. Ensure appropriate control over data, and this comes back to like, it's not like you can share everything, okay? And you know, speaking in the context of NASA, speaking of the context of the Department of Defense, right? It's not like the US is sharing every secret, right? Either. Don't worry. I mean, it's not only health data that needs to be, and the patient's data that will be protected, and we want protected. There's also other type of secrets that are being protected as well, for good or for bad. It's like we can have that discussion another time. But and also nurture respectful relationship with cultural diverse communities. And there's some space in more there. Because sometimes this one goes to the fact that sometimes there are communities that they don't want to share their data for very good reasons. Like one example that always comes to mind is the Maori language speakers. Like with the AI natural language processing thing, it's like, yeah, give me all you have about it. So I train this model and I give you all, and I sell you back all these tools. It's like, well, it turns out the Maori don't want to do that. And it's like, let me learn and see what I do for myself. Then don't help me so much, thank you. I don't know why I keep doing that noise. Okay. So why open science? Well, it is normal science. And this is a tweet by Heidi Siebel in Switzerland. And this, I put this up because like it really resonates. When I was like that young Laura in 1994 in the wet lab reading papers, I couldn't reproduce what was being done by others. I got the nature of the science papers. I was fascinated by it. And there's no way I could keep up with the recipe because there was not enough details in the methods. And then like as a PhD student, there was no way I could reproduce the simulations because there was not enough details in the methods, and so on and so forth. And every scientist in the room can relate to that. Unless, and there are exceptions to that, but the rule is like you don't have enough details to reproduce. But the idea of science is that you can do it, right? That you should be able to do it, because science with everything, if you're given, it's supposed to autocorrect itself, and you can reproduce it. And if it's wrong, oops, that was a mistake. Let's move on over, let's make it better, right? It's the beautiful idea of science and research that it gets broken in the middle because we are humans, and that's lost somewhere. So so this idea, and I heard this before, students and early PhD candidates often don't understand, why are people talking about open science? Wasn't it like this? I mean, is it not supposed to be like this? Well, no. Some things happen in the middle. So open science is just normal science, and then there's a paper behind this as well. I mean, like the early generations do you enter in science thinking that that's the way science should be done, and this is right. That's the way science should be done. it was lost in the middle. Let's recover that idea and start doing it. And why open science? Well, because, well, Houston, we have a problem. Even in places where they ask to share the data and software, they then tested that, and this is just one example of things that cannot reproduce. It's just one paper that shows this, but this is all over the place. Like when you are asked to share data and software, just only 40% made the data available. And then only 26% were able to reproduce the results. And the lack of reproduction of results is because there was not enough methods available. Okay, so we have a problem if we cannot reproduce, particularly when there's all this disbelief in science out there, right? What can we tell to the public? So I think you're all convinced. So, and well, not even speaking about the access barrier to knowledge. So this is Wiley. This is made by Wiley. Again, just one example, but like in the last decade, only about 30% of the papers published are open access. So like that's a big chunk of the world that doesn't have access to publications. And yeah, having to pay to publish doesn't solve that really, because then you don't have access to publish your thing. So it's very complicated. Okay, why open science? It gives you higher exposure, applications, and citations. I mean, if you publish open, you get more cited, 18 to 25%. And it will be more applied, your impact will be higher. But not only the papers, but the data, the code, your lectures, your talks, your blog posts, that's science too. It doesn't need to be in a paper to be science. You can write a blog post, you can write a tweet, you can write in social media. It doesn't need to go into, as of late, it takes so long to take a paper published. And I shown some examples, like things that had taken 2 years to get out. By the time it's out and printed, I just forgot what it was about. So I just write a blog post. It takes like a week to be out. And now there's archive and bioarchive and PsycArchive. So you can put it out first there and give it a digital object identifier. So, okay. So it has higher impact of the research on policy. So it gets to the actual people, what you've done. And it has, taxpayers and those who didn't pay for the taxes also include, and also, it gives access to everyone, including your future self. Have you ever got to a paywall of your own paper? Me too. And it's compliant with finding rules because like funders are more and more considering this kind of stuff. Okay. It attracts better collaboration. I was thinking how many things have come to me just because of publishing things on Twitter. Collaborations, authorships in papers, invitations to talks, you name it. Twitter, really? Not anymore, maybe now when it has been renamed and things, but really it's being out there, being open about and saying what you, and publishing what you do, or even publishing your talk brings other things. And really good collaborators. It shows the quality of your work. You really, it shows what you do and makes it easier also to give credit to all contributors because you use GitHub, GitLab, different platforms that allow to name everyone and show who did what without like, oh, let me see if such and such did that or that. It's easy to track. It can accelerate discoveries. Having the COVID sequence open made a vaccine faster for everyone. It's efficient science because you get to read. I mean, there's a lot of uses of what is produced and even negative results. I mean, you get a negative result, you put it out there, the other persons, I mean, the other groups do not repeat the experiment in vain. So there's a lot of funding saved. And well, increase the diversity of ideas because there's other brains that you don't even know of that are thinking of the same, of different things. And it keeps us statisticians from quoting that to consult a statistician after an experiment is finished is often merely to ask him or her to conduct a postmortem examination. They can perhaps say what the experiment died of. And this is R.A. Fisher. And because open science also includes data management and analysis plans before collecting data, and pre-registration that you may want it or not, okay? So, I mean, it is good all over. I mean, so why now? It's getting a lot more political interest. In 2021, maybe you know, or maybe you don't know this, but UNESCO's 193 member states approved the UNESCO recommendation on open science, and this led a lot of different countries to put forward their policies on open science, including the White House. In 2023 announced the year of open science. Like, so last year was a year of open science in this country. I don't know if you were aware of that. And this is a multi-agency initiative across the federal government to spark open science adoption. And for those in health, it includes the CDC and the NIH. So other than NASA and NSF as well, and you know, a lot of other names that I don't even know what. And there's a comment in Nature if you want about that. You do have the slides in this link, John, if you want them. And at the end, there's another QR code. Okay, but there are fears. I mean, what do you have any fears around open science? Folks online, folks in the room. What do you think? Why would you not do?
Privacy with healthcare is something you have with it. Big obstacle, most of the things I do.
Doug is saying data privacy is one of the obstacles. Yes. What's your name? Nicole.
So I used to manage a data hub at my old institution, and I would see all the research questions people would ask. And oftentimes I had fear that they were creating research that could be weaponized against communities, or their methods were not appropriate for the conclusion they wanted to have. And so that was a big fear that I had.
So I'm saying this for the folks online. So Nicole was running a data hub in a former institution of her, and she thought that maybe the research that was going to be done on the data that she took care of could be weaponized against the communities that the research was targeting. That's a good one. And I'm gonna get to that. Anything else? Anything online? Okay. Let me get to that. Let me go. Yes, and you were, what was your position? You were in charge of the data hub. Okay, was there any IRB? Okay, I mean, that sounds like something the IRB needs to look into, right?
I think so. However, the IRB has generalized knowledge, so they won't know some of the nuances, or they don't have the same statistical knowledge to
Okay.
that piece. And so, yes, I would say yes and no.
Sorry?
I would say yes and no for the IRB having appropriate oversight.
Okay, okay, well, yeah, sometimes with a more complex data projects, IRB needs to speed up. Yeah, that's a more data science complex. Yeah, and I totally understand what you mean. Yeah, yeah, but coming from more from the data science, artificial intelligence fields, then well, but that's not a problem from open science. I mean, it's a problem from having a lot of data altogether. I mean, being open and closed there doesn't really change much, in my opinion.
Yeah, I think it's about stigma, right? I mean, that's, stigma is the problem. If we didn't have stigma, it'd be less.
Well, but you're asking, Alison is saying, and it's about stigma. If we didn't have stigma, then nothing could be weaponized against these communities. Yeah, well, you're asking for even a larger problem. I don't think it's easier to speed up IRBs, I think. Okay.
Laura, what about competent peer review?
Competent, in what, in which sense do you mean
Open
competent?
Science and talking about, well, things don't have to be published or allowed to raise.
Oh, no, well, I didn't say open science says they don't have to, that like, sorry if I can, I said I got bored of waiting for papers to be out, so now I go on blog posts. I didn't say that I'm against peer review or publishing, okay? No, they still need to be reviewed. I mean, it's very imperfect. And things are getting out even through peer review are highly questionable, and there's a lot of problems, and the preprints cannot be taken as peer reviewed ever, and open science doesn't have a saying about it. And indeed, within open science there are movements looking at doing peer review before. It's called pre-review. So just getting your peers and open reviews, like everything goes open. So reviewers need to be a lot more careful, right? Thoughtful. Of course, who pays for that work? That's another thing, right? So no, it still needs to be, I mean, there still need to be other folks. And so, but if you put it forward in the open, others can talk about it. So so I don't know if I answered in a way.
Yeah.
Okay.
I think you're addressing.
Okay.
Steve mentioned that some activities are illegal and people who acknowledge some things could be arrested.
Steve, can you open your mic and say more about it?
Sure. We used to regularly do the Iowa Youth Survey for the state of Iowa, and we would censor data because if a whole bunch of kids in a particular school, the entire sixth grade, admitted to drinking and smoking tobacco or marijuana, we would have to censor that because there have been instances where sheriffs have found out about certain behavior, the youth in a school, and then raided the school. All of the kids, if all of the kids said, yes, they smoke and drank, then they've identified themselves.
Absolutely.
And those activities are illegal for youth.
Yeah. No, that goes to privacy, definitely, Steve, and that needs to be aggregated, identified heavily, absolutely, yeah. Those are the cases. Yeah, sorry.
And those data should not be released to anybody.
Absolutely, thank you. And that goes exactly to the first sphere. Just because you can open, it doesn't mean you should open. So, and open science does not oblige you to make everything 100% open. So safety and privacy goes always first, Other common fears of other people, not you, it's showing your mistakes, being scooped, misinterpretation, maintenance. We can, I mean, we're running out of time, so I'm gonna fly through some of these. There's another thing that comes up often is the misalignment of incentives. You got a Nobel Prize for a new scientific discovery. Years of carefully collecting and curating data plus commenting software doesn't get you any prize. And sometimes it doesn't get you any any money either. So, and not talking about like, it can be, I mean, this is changing, but it can be difficult to find the funds to maintain open data and open repositories, et cetera, et cetera. Funders are changing, likely. And there are risks of around open science, which this is a little opinion piece that we wrote, which is, I synthesize in extractivism, which is others taking that we are very happy sharing everything we do, right? Everything. We share it, like our lectures, and we think very much about our papers, and we are very careful about our data, everything. And then someone else comes and takes it to train generative AI models to do who knows what with them. Well, we know what they do with them, and some of the results are harmful for some populations and some folks. And maybe we don't want to that they do that. So there's a dilemma on should we open or should we not? And there are other types of extractivism, particularly in regions like Latin America or Africa, like we are data producers, and then other parts of the world use them to publish them. So, and the credit doesn't get to those that produce the data, for example. So those are risks around open science as well. And this type of, the risk of generative AI in open science is something that the open science movement is just starting to talk about. So if you're interested in learning more on open science, if you just heard about it today or just starting, this Open Science 101 class, there's classes online, there's courses that you can join throughout the US, summer schools and different, I mean, if you go to this link, you'll find all the alternatives. There's even online classes in Spanish that you can take. It's 5 modules of different topics, very detailed, and you can either, I mean, if you are new to it, it's a very nice compendium of information, and you can learn a lot. If you've been in the movement for some time, you can update your knowledge. If you know it all, you can get a certificate by NASA in a fast track. So it's for everyone. And with that, thank you very much for your attention. And I think we might have 5 minutes for questions.